Here we have a hypothesis test for two populations. Sigma is known, and we're given the hypothesis statements right up here, and the alpha is 0.05. Okay, so sigma is known as it says. All right, and we're given that as well here. Okay, so part A, circle the appropriate description of this hypothesis test. Okay, so in the first one, the null is that mu1 is less than or equal to mu2. Okay, right there I'm looking. And then the alternative is that mu1 is greater than mu2. Okay, so this, again, looking at the greater than sign, this is an upper tail test. So the rejection region is here, and the rejection region is alpha was 0.05. 0.05. So that's the size of that. So part A is it's an upper tail test. The critical value, z of alpha, is going to be 1.645. Okay, so that point is 1.645. That is the cutoff point for our rejection region. And again, that's looking at this portion here is going to be 0.45, and the rejection region is 0.05, right? Because we got 50% on either side of the mean. And the closest value to 0.45 in the table is splitting the difference between 1.64 and 1.65, and that's where we come up with this 1.645, as we've talked about several times in class. Okay, so the decision rule then is if the test stat, which we'll calculate using the equation right there, is greater than z of alpha, z of alpha 1.645, we will reject the null, otherwise do not reject. Okay? Again, just saying, if it falls in the rejection region, we'll reject the null, otherwise we will not. Okay, what is the value of the test statistic? So that's what we're going to calculate here. We got x bar 1 minus x bar 2, 144. This is z. 144 minus 129 minus, and then this, in our case, as we talked about, we're saying that there's no difference there. So for our purposes, this is going to be 0, mu1 minus mu2. Sometimes that could have a value, but not for what we're working with here in any of our problems. So that's going to be 0. And then here we've got the denominator, which is the square root of 11 squared over 40 plus 16 squared over 50. Okay, and I'm just getting the 16 squared over 50, 11 squared over 40 right out of the table there. And our answer then is, when we calculate all this out, we get 5.26. So this result, or these results of these two, are 5.26 standard deviations above the mean. So that is kind of off the charts, right, out here in the rejection region. Therefore, we will reject the null and say that that mu1 is greater than mu2. All right, so there's a difference between these two populations.